Good morning, ma'am. This is Sadhyanj from the Department of Computer Science and Engineering from the section E, first BTech second semester. So my topic for the second assignment is show that del square into f of r equals to f double dash of r plus 2 by r f dash of r. So in my topic, I have to prove that del square into f of r is equals to f double dash of r plus 2 by r into f dash of r. So let's move to the deep inside my topic. So before going to solve my problem, uh, I have to know what is the vector differentiation, what are vectors. So firstly, vectors. A physical quantity which has both magnitude and direction is called vector. For example, weight, displacement, velocity, force, acceleration. These are the quantities which comes under the vectors. So next, vector differential operators. Vector differential operators are nothing but they are the fundamental tools in vector calculus. They are used to perform operations like finding gradients, divergence, and curls of scalars and vector fields. They are often represented by the symbol del and they are pronounced as del or nabla. So, with having the knowledge and about the vector differential operator, I should know what is Laplacian operator. So, the Laplacian operator is often denoted as delta or del square. It is a differential operator that calculates the divergence of the gradient of a scalar function, essentially measuring the rate of change of a function's second derivatives. It is nothing but it is also a fundamental tool in various fields, including physics, engineering, and computer science, appearing in the equating describing phenomena like heat diffusions, wave propagations, and potential fields. Okay, now we can solve our problem. So what is our problem is here del square into f of r equals to f double dash of r plus 2 into f dash of r, and they have given r equals to modulus of r bar. So to solve this problem, we have Laplacian operators. By Laplacian operator, we have del square equals to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. From LHS, dou square into f of r. We can write in the place of dou square del square, we can write dou square by dou x square plus dou square by dou y square plus dou square by dou z square. And we can write f of r as it is. We write dou square by dou x square plus dou square by dou y square plus dou square by dou z square as summation of dou square by dou x square. Say summation of dou square by dou x square is equals to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. And f of r is as it is, we can write summation. So dou square by dou x square, we can write it as dou square by dou x into dou by dou x. So summation dou by dou x into dou by dou x into f of r. After differentiating f of r with respect to of x partial differentiation, we get f dash of r into dr dou r by dou x. And say a summation dou by dou x as it is, we can write. And we know that we can write dou r by dou x as x by r. So summation dou by dou x into f dash of r into x by r in the place of dou r by dou x. Okay, we have some properties and the terms are in the form of u by v. So here u by v are x into f dash of r by r. So here we take u as x into f dash of r and v r as v. So u by v equals to v into du by dx minus u into dv by dx. We can apply this property in our problems. So in the step v here v is r dou by dou x into f dash of r means here du by dx minus here u equals to x into f dash of r and dou by dou x and v is r. So dou v by dou x as dou r by dou x by v square. We have taken r as v, so v square equals to r square. So we have applied this formula in our problem. So next, r into dou by dou x into f dash of r. In this term, we have x into f dash of r. So here we get the property of uv. So we, after differentiation of uv, we get u, we can write it as u into d by dx of v plus v into d by dx into u. So here we take u as x, v as v double f dash of r. We apply this in our problem. So we get, we can write r outside. To x into f dash of r, we apply this formula, then we get, we can write x as it is because it is u. D by dx, v is f dash of r. We can write, after differentiating f dash of r, we get f double dash of r. And the r is internal term, so dr by dx plus v f dash of r. We differentiate x with the respect of x, we get 1. So minus x into f dash of r into x by r, we can write this term as it is. We have done no changes to the term. Next, after applying that formula, we got here, we multiply the outside r to the other inner terms, to both terms. Then we get r into x, f double dash of r, x by r, because we write dou r by dou x as x by r. Plus we here also we multiply with r into f dash of r minus x square. In the last term, we have the two terms of x's. So we write that x square into f dash of r by r as it is by r square. So after that we get, in the first term also we have two x's. So we multiply the both terms. Then we get r into f double dash of r into x square by r plus r into f dash of r minus x square f dash of r by r square. We take the LCM in the numerator. We can see in the above numerator, we have the two like terms. First term and the last term, they have the same denominator r. But the middle term has no denominator. So we take LCM in the numerator only. After taking numerator, let's see what's happened. After taking numerator, the LCM in the numerator, we get r square in the middle term. That is, we get r into f double dash of r x square plus r square into f dash of r minus x square into f dash of r by r. We have already r square in the denominator. After taking above denominator r, then we get denominator as whole r cube. So numerator is not changed. After separating the whole terms, three terms separated, then we can write them separately. Summation x square f double dash of r by r square plus f dash of r by r minus x square f dash of r cube. So now we can write summation of x square. Then f double dash of r by r square summation x square plus 1 by r summation f dash of r minus f dash of r by r cube summation x square. We know that summation x square equals to r square. In the place of whole summation of x square, we write r square. Summation of f dash of r is 3 into f dash of r. So in the place of summation x square, we have kept r square. Then we can see in the first step f double dash of r by r square into r square plus 3 by r into f dash of r minus f dash of r by r cube r square. In the last term, we can see that r square and r cube got cancelled and we have r in the denominator. And here in the second term, we have no r's in the numerator, so no cancellation. In the first step, we have the both in the numerator and the denominator r square. Then they both get cancelled. We are left with f double dash of r only. We can see that the last two terms are the similar, so that we can subtract the both terms. Like 3 by r into f dash of r minus f dash of r by r. We get 2 into f dash of r. So RHS f double dash of r plus 2 f dash of r. This is equal to RHS. Hence proved LHS is equal to r square. Thank you, ma'am, for this opportunity.